Worksheet 5, sections 1.1 and 1.8. Taking a look at what I have in store for us now. I'm looking for the equation of a circle with a center at -1, 3 and a radius of 9. Well, the standard form of a circle with a center of hk and a radius of r is x minus h squared plus y minus k squared is equal to the radius squared. So for this specific example, my center is -1, 3, so my equation will be x plus 1 squared plus y minus 3 squared is equal to the radius, 9 squared, would be 81. There's my equation of my line. If I'm writing the center and radius of a circle, so going backwards, here my center will be at -2 and 0. Y coordinate is 0 here. And my radius is the square root of 36 over 49. So my radius is 6 sevenths. Here's my center. Here's my radius. Solving higher power inequalities. Well, first I'm going to have to find my critical values. Critical values occur when the equation is equal or undefined. That's where my two critical values will be. Once I find them, I'm going to plot them on a number line. Then I'm going to plot or check test points to see which values of x in which intervals will work for this inequality. I'm going to check test points. So let's get started. For my first one, to find my critical values, I'm going to first check when this is equal. So when x cubed plus 2x squared minus 4x minus 6 is equal to 2, which would occur when x cubed plus 2x squared minus 4x minus 8 is equal to 0. I brought my 2 over. Then I can factor this by grouping. So I can factor x squared out of my first two terms. Be left with x plus 2. I can factor a -4 out of my last two terms. A minus 4 times x plus 2. I now have a common factor of x plus 2. I'll factor that out. And when I solve this equation, I get either x is equal to -2 or x squared is equal to 4, so that x would be plus or minus 2. Next, I'm going to plot these numbers on a number line. I really only have two different answers, -2 and +2, so I only have to do 2 points, -2, +2. And I'm going to get test points in between each of these values and outside of them. So one value between -2 and 2 is 0. One value greater than 2 would be 10. And one value less than -2 would be -10. So these values I will plug into my inequality, my equation, to see which intervals my values for x will make this inequality true. Now, you have two options. You can either plug it into the original equation, but I'm going to do a slightly simpler process by plugging it into my reduced equation. So I'm going to be checking each of these test points in the equation. X plus 2 times x squared minus 4, whether or not that is less than or equal to 0. If something is less than 0, that would mean that it's negative. So I only have to look at the signs of each of these. If I plug in -10 first, -10 plus 2 would be -8. This is negative. -10 squared is 100. Minus 4 is 96, which is positive. A negative times a positive is a negative number, which is less than 0. So this, values in this interval, would work. Next I'm going to check 0, my middle value. 0 plus 2 is 2. 0 squared minus 4 is -4. This is a positive and a negative number, which together make a negative number, which is less than 0. So these values would also work. Finally, I'm going to check 10. When I plug in 10, I get 10 plus 2, which is 12. Over here, I get 100 minus 4, which is 96. It's a positive times a positive, which is a positive, which is not less than 0, so that will not work. This is equal does not work. What I end up with as my final answer is that values of x that work are in this interval and in this interval, but not over here. And since this is a less than or equal to portion, whenever the equation is equal, those points would also be included. So I will be including the points where my equation is equal to 0, including those two. So my final values would be all values of x, which are to the left of negative, to the left of 2. So x has to be less than or equal to 2. Those values of x would make this equation. Okay, moving on to the second part. For b, 5 over x minus 6 is greater than 3 over x plus 3. Now, just like before, I'm going to find my critical values, but now I will have some points where these are undefined. Specifically, when x is 6 and when x is negative 3, each of my fractions will be undefined. So these are also critical values that I will have to consider, as well as when it is actually equal to. So I'm going to look at the equation version. 3 over x plus 3. Solve this equation by cross multiplying. I get 5x plus 15 is equal to 3x minus 18. Bring all my x's to one side and my constants to the other. This will be negative 33. And when I solve for x, I get x equals negative 33 over 2. So that's another critical value. And now I put all these critical values on a number line to help me get a better idea of where this value is in relation to the other two. I could do this division. If you notice that 32 is the closest even number, so this is going to be negative 16 and 1/2, which is much less than negative 3. So this will be my smallest value, negative 33 over 2. My next largest, negative 3, and my largest value, 6. That gives me my break in each of the intervals. Then I'm going to get some test points, throw in, say, negative 20, maybe negative 5, and 0, and maybe 10. These are just any points in the interval so that I can see what the behavior of this inequality is in those intervals. So, again, now I'm going to plug this into my original equation. When I do that, I end up with 5 over negative 26 being greater than 3 over negative 17. If you're unsure whether that's true or not, you can type them into your calculator. It turns out that this is actually more negative than this, which makes this larger. So this is not true. This interval will not work. When I move on to my next test point, negative 5, I end up with 5 over negative 11 is greater than 3 over negative 2. If you notice, 5 over negative 11 is less than 1. 3 over 2 is greater than 1. And since these are negative numbers, this number is more negative, which makes it smaller than this one. So this interval will also work. Again, if any of this, you're not comfortable with working with fractions, you can always type these into the calculator and check yourself that way. For my test point of 0, if I plug in 0, I get 5 over negative 6 is greater than 3 over 3. Well, a negative number can't possibly be greater than a positive number, so this won't work. Moving on to my next one, positive 10. I end up with 5 over 4 is greater than 3 over 13. Well, if you notice, this number is less than 1, and this one is greater than 1, so yes, this must be true. Something greater than 1 is greater than something less than 1. Once I've done all those test points, I know which intervals work, and then I just have to summarize that solution. So I know that for values of x greater than or equal to, once I've got those test points, I just have to summarize my solution. So I know for values of x between negative 33 over 2 and negative 3, I will have solutions that make this equation valid. Notice that there's just a greater than sign. There is no equals portion, so I will not be including in an equals portion on my solution down here. And besides this interval, there is also this interval for values of x greater than 6. So either x is between negative 33 over 2 and 3, or x is greater than 6. Those would be my two solutions. Also, sketching them on the graph is useful for helping you decide where your interval actually is.